In this video, we will look into apheresis machines. In this video, we will look into the beginning of apheresis machines, what are apheresis machines, the principle of apheresis machines, and the types of apheresis machines. Let's look into the beginning of the apheresis machine. Prior to the invention of the apheresis machine in 1972, blood had to be collected and mechanically separated into its various components to treat specific medical conditions. This arduous process required a lot more blood to be donated in order to treat a patient with the blood component they required. Thankfully, in the 60s, a man by the name of Herb Cullis came along and began working on a machine that would revolutionize the blood donation process. Cullis was an American medical technologist who knew he wanted to use his skill set to help others ever since he began his studies at the University of Maryland. In 1965, Cullis got the opportunity to do just that when the American Instrument Company hired him and tasked him with building a machine that draws blood from donors, separates platelets out, and returns remaining blood components. By 1972, Cullis was able to successfully build the first blood separator, Fenwal CS3000, with 7 other team members. The term apheresis, a Greek word for to separate, was coined thanks to Cullis's work and started to be used as a clinical term in 1979. Let's know what the apheresis machine is. An apheresis machine is a device which receives blood removed from a patient or donor's body and separates it into its various components: plasma, platelets, white blood cells, and red blood cells. Depending on the reason for apheresis, one of these components is isolated and collected by the instrument, while the others are returned to the body. Depending on the substance that is being removed, different processes are employed in apheresis. If separation by density is required, centrifugation is the most common method. Other methods involve absorption onto beads coated with an absorbent material and filtration. Let's learn about the types of apheresis machines. The centrifugation method can be divided into 2 basic categories. The first method is continuous flow centrifugation. Continuous flow centrifugation, or CFC, historically required 2 venipunctures, as the continuous means the blood is collected, spun, and returned simultaneously. Newer systems can use a single venipuncture. The main advantage of this system is the low extracorporeal volume, calculated by volume of the apheresis chamber, the donor's hematocrit, and total blood volume of the donor used in the procedure, which may be advantageous in the elderly and for children. The second method is intermittent flow centrifugation. Intermittent flow centrifugation works in cycles, taking blood, spinning and processing it, then giving back the unused parts to the donor in a bolus. The main advantage is the single venipuncture site. To stop the blood from coagulating, anticoagulant is automatically mixed with the blood as it is pumped from the body into the apheresis machine. And the third method is centrifugation variables. The centrifugation process itself has 4 variables that can be controlled to selectively remove the desired components. The first is spin speed and bowl diameter. The second is sit time in centrifuge, the third is solutes added, and the fourth is not as easily controllable, plasma volume and cellular content of the donor. The end product in most cases is the classic sedimented blood sample with the RBCs at the bottom, the buffy coat of platelets, and WBCs, lymphocytes and granulocytes, PMNs, basophils, eosinophils, monocytes in the middle, and the plasma on top. How does the apheresis machine work? Apheresis units incorporate polyvinyl tubing that draws blood from the patient and moves it through centrifuges and/or filters to separate blood products. The blood is then returned to the patient via tubing or is collected in bags, often suspended from a pole, for donation or disposal. A display and control panel allow the operator to program the unit and view progress and/or alerts. Safety features include pressure sensors, ultrasonic air bubble detectors, optical fluid level detectors, and dry heat fluid warmers. The warmers prevent hypothermia caused by infusing low-temperature fluids. The unit may have wheels or it may be placed on a cart. The operator programs the unit to run the desired separation protocol. The unit automatically controls the centrifuge, pump, and other settings. Rotary peristaltic pumps draw blood from the patient or donor and pump blood through filters or centrifuges. Filters separate blood components based on size, centrifuges separate by density. Optical sensors detect plasma cell interfaces to minimize contamination from other components. Centrifuges have inlet and outlet ports and compartments to keep components separated. Pumps move the blood products into collection bags, add anticoagulant, and reinfuse fluids. Replacement fluids, e.g. saline, serum albumin, plasma protein fraction, fresh frozen plasma, are infused into the patient to maintain appropriate intravascular volume and pressure. Let's end this video with the operating steps of an apheresis machine. First, the apheresis machine is wheeled to the bedside or donor chair. Second, the operator connects the sterile tubing sets, also called apheresis sets, to the patient or donor. Third, as the patient's blood is pumped into the machine, an anticoagulant is automatically added and the blood enters the chamber. And finally, blood components are separating using centrifugation and/or filtration. The method of separation depends on the product that is to be removed or collected from the blood. We hope you like this information on apheresis machines. If you like this video, hit that like